Okay, this is a two-sample t-test. You can see it has the means and the standard deviations and the sample sizes. The first thing you need to do on you can do your research hypotheses is they're different, so it's going to be in the research mu A not equal to mu B. But when we do the analysis, the first thing we want to do is check to see whether one variance is greater than or equal to twice the other variance. So I will take 6.4 squared to get the variance of the first group and 7.4 squared to get the variance of the second group, and you can clearly see, I hope, that neither of those is twice the other. Therefore, when we run our test, we will pool the variances. So stat tests two-sample t-test, and this time we're inputting the actual statistics. If we had those 25 numbers each, the actual data values in two columns, we would run it just like this, but we actually are given the statistics this time. And so now we will just enter those statistics into the menu. So for the first group, 21.4, 6.4. You are entering standard deviations, not variances here. And 25. And 19.8. 7.4. 25. Not equal to. And pooled. Then just hit calculate. And there we have it. The t-value of 0.817 is quite low. You would expect then, as we have a p-value of 0.4176 about. Anyway, that's going to be not less than, or greater than, not less than any level of significance it's likely to be used. In this case, it's 0.05. Since we're not less than 0.05, this will be a fail to reject HO. You can also see this does give you the means over here. And if you were to arrow down, it also has the two standard deviations. And then the pooled standard deviation, which we really haven't talked about. We've been computing the pooled standard error altogether. This is actually what you would get if you just did the first part of that fairly long equation for pooled variance. It doesn't have, in other words, the one that I have, don't multiply by this square root of 1 over NA plus 1 over NB. It's the other part where you weight the standard deviations. But that's it for the two-sample t-test. Again, stat tests, two-sample t-test. Enter the data. Get your research hypothesis in, tell it where to pool or not, and calculate. One other thing I should show you here, and that is that stat test can also go down and get any confidence intervals that we want. And we want to get a two-sample t-interval. So this is the confidence interval for the difference between two means. The data will already be in there if you've just run the hypothesis test. And let's say we wanted a 90%. You can either put 0.95, 0.9. You can just put 90 or 95 too, in this case 90. And calculate. And you will see the interval goes from minus 1.682 to positive 4.8819. That interval includes 0, so there is the potential or the possible. It's plausible that there is no difference between the two population means. They could be equal.